All right, folks, Mr. Bucko here with your target from section 13.5 and 13.6 out of the geometry book, where we are trying to use trigonometry functions to find missing measurements of right triangles. So we're going to introduce you to some of the buttons you may have seen on the calculator before, and we're going to start using those things to find missing measures of right triangles. So done a lot of work with the right triangle so far, and we're going to do some more to find missing side lengths here. And we're going to first talk about the definition of a tangent, or of the tangent function, or the tangent ratio here. And suppose that we have a triangle ABC that's a right triangle with right angle C, as indicated in the picture here. The tangent of angle A. So the tangent of angle A, written tan A. So you've seen that button tan on the calculator before. We're going to start using that thing. The tangent of whatever the measure of angle A is the length of the leg opposite to angle A divided by the length of the leg adjacent to angle A. So we have to know what opposite and adjacent mean with respect to an angle. We've done this before when we did the triangle congruence theorems. So this language isn't new to us. Maybe difficult, yes, but new, no. So that's what the tangent of angle A is. So if I know what angle A is, here's angle A right there. The leg that's opposite of angle A is over here. This is the leg that's opposite to angle A. And the leg that's adjacent to angle A is this one right here, because it's right next to it. Notice this leg is not adjacent to angle A, because this isn't a leg at all. It's the hypotenuse of the right triangle. It's the longest side. Subsequently, if this is angle B, this is the leg that's opposite of angle B, because here's angle B, and this leg is on the opposite side of the triangle. So that's where the word opposite comes from. It's on the opposite side. And then this leg that's opposite to angle B, or opposite to angle A, I'm sorry, is adjacent to angle B. That's what that is there. And the tangent ratio, so in this case, if we're looking at tangent of angle A, if we know what angle A is, or if we don't know what angle A is, the tangent of angle A is equal to the ratio of the leg opposite of angle A divided by the leg adjacent to angle A. That's what the tangent ratio is. It'll make a little bit more sense when we put this into context and do an example. So let's do that. So suppose that we have a flagpole here, and at a location 30 meters from the base of the flagpole. So here's the base of the flagpole, and then this point A is 30 meters away. The angle to the top of the flagpole is 34 degrees, as indicated here. So this angle from here to here is 34 degrees. We want to determine the height of the flagpole to the nearest meter. So we want to find out how tall the flagpole is. We know one side here, it's 30 meters as indicated. We know this angle is 34 degrees. We don't know exactly how long this line is. We don't know how tall the flagpole is. We want to figure out how tall the flagpole is. We can't use the Pythagorean theorem here because we don't know another side length. We only know one. We can't use the idea of special right triangles in this case either, because this is not a special right triangle. It's a 90-degree angle and a 34-degree angle. So we can't use any rules of special right triangles. We will resort to using our trig functions here. And in this case, we're going to use tangent. How do I know we need to use tangent? Here's why. I know angle A. I'm looking for the opposite side from the angle, and I have the adjacent side of the angle. So I'm looking for the opposite. I know the adjacent, so I'm going to use the tangent function here. What I'm going to do is say that the tangent of 34 degrees, this is when you type in the tangent button into the calculator and say it equals 34, and you'll get a number. That number is equal to the length of the leg opposite of angle A, which in this case is the height of the flagpole, divided by the length of the leg adjacent to angle A. In this case, it's 30 meters. So what does that look like when we plug in the numbers? The tangent of 34, whatever this number is, and we're going to use a calculator to evaluate that, is equal to whatever this length is, BC. In this case, it's the height of the flagpole, divided by 30. Why? Because the tangent of any angle A is equal to the leg opposite that angle divided by the leg adjacent to that angle. So this, while it might look complicated, is just a very basic algebraic function. So what I'm going to do here is just multiply by 30 on both sides to get this side length BC all by itself. Dividing it by 30, so then I'm going to multiply it by 30. And then I have 30 times the tangent of 34 degrees. I don't know what the tangent of 34 degrees is. I'm going to type that into the calculator and figure out what that is. It turns out it's approximately 0.67450, so on and so on. And we're going to take that value. This is the tangent of 34. If you type tangent of 34 into the calculator, you're going to get this value. And then multiply by 30, that is going to be the approximate value of BC, or the height of the flagpole, because this will be a decimal approximation of that, which will be about 20.235 meters. So to the nearest meter, the height of the flagpole is 20 meters, because it's 20.2, and it says to the nearest meter would be 20 meters.